Assalamu alaikum. I am Jannatul Mawa. The topic I am going to discuss is activity selection problem. Here is the contents which I am going to discuss about. Here is the introduction of activity selection problem, background of activity selection problem, and the steps of applying greedy approach on activity selection problem. And I will show some simulation of activity selection problem. Then I will show the algorithm and code implementation in NetBeans. Then I will show a sample input-output of activity selection problem. Then I will analyze the complexity of activity selection problem. After that, I will show and explain why this problem is called optimal. Then I will show some sector where we can apply this algorithm. At last, I will show the references from where I have collected all the information about activity selection problem. At first, I am going to discuss about the introduction of activity selection problem. Actually, activity selection problem is a combinational optimizable problem. And activity selection problem is always conscious about non-conflicting activities. Each event has its own starting and finishing time. It follows a schedule, and if any event causes any kind of collapse, then it will eliminate it. This problem is also called a concurrent scheduling problem. Then I am going to discuss about the background of activity selection problem. And here I am discuss about which things allures people to choose this algorithm. At the earliest time, this algorithm was used for scheduling a room to avoid multiple conflicting schedule time. As each event has its starting and finishing time, so there is no chance or option of overlapping event schedule. Now I am going to explain the steps of applying greedy approach on activity selection problem. First, we have to sort the activities or event according to their finishing time in ascending order. After that, we have to select the activity which has the least finishing time and we have to print it. At the last step, we have to compare the finishing time with the starting time. And if the starting time is greater or equal to the finishing time, then we will select that activity. And if any other activity don't follow this condition, the activities will be eliminated. Here, I am going to explain the simulation of activity selection problem. In this slide, we can see two tables, and the first table is unsorted. The second table is sorted according to their finishing time in ascending order. As A3 has the least finishing time too, so A3 will be first selected. A3, A2, A1, A5, A6, and A4. These have 2, 4, 6, 7, 9, 9 finishing time sequentially. At the step 2, as we know, we have to select the first activity which has the least finishing time. As number A3 activity has the least finishing time too, so we will select it and print it. At the step 3, as we know, we have to select those activity whose start time is greater or equal to the finishing time. Here we will compare in between or among those activities. Here we will first compare between A3 and A2. A2 has a finishing time. A2's finishing time is 2. A3's finishing time is 2 and A2's starting time is 3. 3 is greater than 2, so A2 will be granted. Then we will compare A2 and A1. A2's finishing time is 4 and A1 starting time is 0. 0 is less than 4, so A1 won't be granted, it will be eliminated. Then we will compare A5 with previously done activity A2. A2's finishing time is 4 and A5 starting time is 5. 5 is greater than 4, so A5 will be also granted. Then we will compare A6 with previously done activity A5. A6 starting time is 8 and A5's finishing time is 7. 8 is greater than 7, so A6 will be also granted. Then we will compare A4 with previously done activity in the same way. A4's starting time is 5 and A6 finishing time is 9. As 5 is less than 9, so this activity will be also eliminated. And by using this condition, the selected activities will be A3, A2, A5 and A6. Now I am going to explain the algorithm of activity selection problem. At the first step, we have to take three array ASF, which contains activities starting time and finishing time sequentially. Then we have to sort the activities according to their finishing time in ascending order. Then we will create a set named S which contains the selected activities, and we will store the activity which has the least finishing time in index 1. Then at the step 4, we'll create a variable k to keep the track of the activity. Then we'll find out the length of n, which contains the number of activities. At the step 6, we will start from the index 2 as we give the first activity in the index 1 up to n. Then we apply the condition, that is, if the starting time is greater or equal to the finishing time, the activity will be granted and it will be added to the selected activities set. At the step 9, the index of the last selected activity is updated to the just added activity A of I. Then we will return S, that means the selected activities according to the condition. Here is the code implementation of activity selection problem. First, I want to explain the main function. Here I have taken a variable n named n which contains the number of activity. Then I have taken two arrays named S and F which contains starting time and finishing time sequentially. And I also declare a function which contains S, F and n. That means starting time, finishing time and the number of activity. Here I am going to the function. Here, as step 1 condition, we have to sort the activity in ascending order. In step 1, I have sort the activity in ascending order. Here we can use any kind of sort like merge sort, heap sort, quick sort. At the step 2, I have selected the first activity according to its finishing time, which has the least finishing time, and I have printed. At the step 3, I have applied the condition, and that is, if starting time is greater or equal to the finishing time, then the activity will be printed. And thus, applying this implementation, we can find out the maximum number of activities. Here I show a sample input-output of activity selection problem. Here first I gave the length of the array 6 and then enter the elements of the array sequentially. That is the array which contains the starting time 130585. Then I enter the finishing time, and that is 246799. Then I apply the sorting, and that according to the finishing time, and the output becomes 1, 2, the output set becomes 1, 2, 3, 4, 5, 7, 8, 9. Here is the complexity analysis of activity selection problem. We use in activity selection problem the greedy approach. The time complexity of activity selection problem is big O of n log n when it is not sorted, and it will be big O of n when it is sorted. Here n is the number of activities. Here I will explain the reason for which activity selection problem is called optimal. Here, greedy approach is used to find the solution since we want to maximize count of activities. And greedy algorithm approach choose an activity with the earliest finish time in every step. And that's why activity selection problem is called optimal. Here I show some sector where we can apply this algorithm. We can apply this algorithm for scheduling multiple events in a row, as it has each event has its own start and finishing time. We can use manufacturing multiple products by using this algorithm. We can also use this algorithm in operation research for dealing with real-life business problems. Here is some references from which I have collected this information: Wikipedia, YouTube, Google, Geeks for Geeks, Algorithm by Study Tonight, and Educative.io. At last, I want to thank everyone for listening my presentation, and special thanks to our respectable ma'ams, Lintesla ma'am and Sonia Koraya ma'am.
My presentation topic is job sequence algorithm with deadline. So these are the contents of my of this algorithm. Here we will first see the background. We'll move to introductory part. Then we will see the approach to this solution simulation. Then we will move to algorithm part and code implementation. Then we will analyze the complexity of this algorithm. Then we will see some real life applications. So let's move into it. So what is the background of this algorithm? This algorithm is basically a greedy algorithm. So first we have to understand what is greedy algorithm. Greedy algorithm is basically a solution that builds up step by step, and it always chooses next most obvious and immediate benefit, and eventually we get the optimal solution. So let's move to the introductory part. The sequencing of jobs on a single processor with deadline constraint is called as job sequencing with deadlines. So here we will be given a set of jobs with their deadline and associated profit. When we complete the jobs, we will have a profit, we will have the maximum profit, and which will be the optimal solution for us. The next point is only one processor is available for processing all the jobs. The most important thing is all the job must be proceed by only one processor. What one processor or uniprocessor means? This algorithm is basically a uniprocessor system. So what uniprocessor refers to? Let's say we have 3 jobs and we have only one person to complete all the jobs. It's not like that we have 3 person to complete 3 jobs. We have only one person to complete each job one at a time. So we can say this is a uniprocessor system. So the next point is processor takes 1 unit of time. So we have to understand what 1 unit of time means. Let's say we have a job and its deadline is 3. We can take these 3 in any unit. It can be 3 seconds, 3 minutes, 3 months, 3 years, in any unit. Let's say we are taking 3 months. So we have to complete the job in any month of these 3 months. It's not like that I am starting completing the job in first month and finishing the job in third month. It's not like that. I can either choose first month to complete the job, or second month, or third month, in any month of these 3 months. So this is so we are taking 1 month, or we can say 1 unit of time. So the main motto is we will complete the job, one job at a time, and then we will get the profit. So the problem states, how can the total profit can be maximized if only one job be completed at a time? So let's move to the approach part. So what's our idea? Our idea is we will complete the job one at a time within its deadline. Then we will have some profit of their associated profit with their jobs, and it will eventually give me the maximum profit, and that will be our optimal solution. So let's how greedy algorithm helps us. Greedy algorithm is basically a step-by-step approach which gives me the next best beneficial, next best obvious and immediate benefit. So greedy algorithm is adopted to determine how the next job is selected for an optimal solution. So our approach would be, step one, we will sort all the jobs in decreasing order of their profit. So we will sort all the jobs in decreasing order of their profit. Step two would be, we will check what is the maximum deadline. And then we will draw a net chart. Net chart is basically a table diagram. So we will draw a net chart where it starts from 0 and ends with the maximum deadline. So as it is said, draw a net chart where maximum time on net chart is the value of maximum deadline. So it will start from 0 and ends with the maximum deadline. The step 3 would be, we will pick up the jobs one by one and we will put the jobs into the net chart. But we have to very concerned about that. We will put the jobs as far as possible from 0 and also ensure that the jobs are getting completed within its deadline. So let's see the simulation part. Let's say we have these jobs associated with their deadlines and their profit. So our step 1 is, we will sort all the jobs in decreasing order of their profit. If we do so, we will get these jobs in decreasing order of their profit. And let's see another thing. What is the maximum deadline? The maximum deadline is 5. So it will help me in step 2. So remember that the maximum deadline is 5. So step 2, as I said, the maximum deadline is 5. So we will draw a net chart. This is my net chart. It will start from 0 and ends with 5. 5 is basically the maximum deadline. Now we will pick all the jobs from step 1 and put all the jobs in this net chart. So step 3 would be, we will take job 4. The deadline is 2. So this is our net chart. We can complete the job in first month or second month, but according to the algorithm, we will put the job as far as possible from 0. So we will put this job 4 into the second slot. If the second slot is empty, yes, we are seeing that the second slot is empty, so we'll put the job 4 into the second slot. Step 4 is same as before. So the deadline of job 1 is 5 according to the algorithm. We will put job 1 as far as possible from 0. So we will put job 1 into the 5th slot. Step 5 is also same. We will put job 3 into the 3rd slot if it is empty. So we will putting the job 3 into the 3rd slot. Step 6, the deadline of job 2 is 3. So according to the algorithm, we will put job 2 into as far as possible from 0. But here is a problem. If we want to put job 2 into 3rd slot, we will see that the 3rd slot is not empty. So we'll move to 2nd slot. 2nd slot is also not empty. So we will move to 1st slot. And we see that the 1st slot is empty. So we'll put job 2 into the 1st slot. Step 7 is also same as before. We are the deadline of job 5 is 4. So we'll put job 5 into the 4th slot. So now if we see, what we are getting? We are getting job 2, job 4, job 3, job 5, job 1. The only job left is job 6. Its deadline, the job 6 deadline is 2. But as we can see, there is no empty slot. So job 6 cannot be complete within its deadline. So finally, what we get? We get an optimal schedule, which will give me the maximum profit, and it will give me also the maximum profit. If we proceed in this sequence, it will give me the maximum profit. So part 2 says, as I said earlier, all the jobs are not completing within the deadline. So job 6 is left because all the slots are occupied. And part 3 says, if we proceed in this sequence, we will get the optimal solution. I mean, we will get the maximum profit. So if we sum all the profit in this sequence, we will get the maximum profit, which is 990. So this is basically my job sequence algorithm, and this is the optimal solution, and this is my maximum profit. So let's move to the algorithm part. This is my algorithm. We will run a loop from 1 to n. N is basically the maximum deadline. Then I am putting I'm taking the minimum value of Dmax and deadline I. What Dmax refers to? Dmax is maximum deadline, and deadline I refers to the I position profits deadline. So I'm taking the minimum value to K. So we will run another loop where K greater than equal to 1. Why we are doing so? Because we don't have any slot before 1. We are starting from 1. Okay, if time slot of K is empty, then we will put the job into that time slot. If this not works, then we will decrease K value and see which slot is empty. Then eventually we will end the loops. And let's move to code implementation part. So this is basically my code. Now I would like to take you on NetBeans to give you more clear view of this code. So excuse me for a few seconds. Thanks for waiting. So this is basically my code. So let's move to the main function. So here in this main function, I am taking an array list of type job. Job is basically the class. Here is the class job. So I'm taking an array list of type job, and I'm calling the parameterized constructor, creating the object, and putting the object in this array, adding the object in this array. Then I'm creating the object of job, and I'm calling this function passing with this parameter and the maximum deadline. So let's move to our class. So here I have taken ID variable of character type, deadline and profit of integer type. So this is basically a default constructor. You can take it or not, it will not affect the code. This is my parameterized constructor, which I am calling and putting the job and deadline and profit to store this. I'm taking a p variable of integer type, which will give me the maximum profit, which will sum up the profits. So this is my function where I have passed the array and the maximum deadline. So collection.sort is basically I'm using the Java's comparator. It will help me to sort in descending order in terms of profit associating with the deadline and its job. I have taken a result array of Boolean type and job array of character type, and the size of each array is maximum deadline. So I'm running the loop, the outer loop from I to n, and in inner loop, I am taking the minimum value between the maximum deadline and the ith position deadline. So if the result of I if the result of J is false, I mean the slot is empty, then we will make it true, and then we will put the job into this array, into this character array, and we are adding the profits into the P, and we will eventually break it. If we do run this loop, it will give me the optimal solution, I mean the maximum profit. By the help of for Hens loop, I have taken I have printed all the jobs sequence, and finally I have printed the maximum profit. So let's move to our slide again. So basically this is my output. So it will give me the maximum profit, and this is the sequence of my optimal solution. So let's analyze some complexity, the time complexity. So when we sort in descending order, the time complexity will be n log n. Let's say the existing jobs are m, and we are searching for empty slot n times. So the time complexity will be order of n into m. If we consider that the existing job and the deadline are in same, so we can say the existing job is n, and we are searching for empty slot n times. So it will be order of n into n, I mean order of n square. So it will give me the time complexity of order of n square. And this is the time complexity for all three cases. It is the time complexity for best case, worst case, and also average case. So there are some applications. This job sequence is basically very much used in field of networking. Or if I can give a real life application, let's say we want to visit some places, let's say 5 places we want to visit within a time. To be very concerned about the traffic, in what sequence I will visit and which will give me the more benefit or more profit. So it can be a real life application. So these are the references I have gathered this algorithm. I have watched some videos and a website, Geeks for Geeks. So thank you so much for your patience, and very much thankful to Linta ma'am and also Sonia ma'am. Thank you so much. Assalamu alaikum.